Hey everybody, in this video we're going to talk about the reciprocal function. This thing's also sometimes called the inverse variation when you're talking about inverse and direct variation. So you'll see it in two different ways, the reciprocal function or as the inverse or as inverse variation. So what is the reciprocal function? Well, it's when we have y equals k over x, where k is some constant number. That constant can be a positive, it can be a negative, doesn't really matter. It's a constant number though. And what we're going to see when we look at this is that when the x value increases, because this is a fraction, we're going to see that the y value is decreasing. And similarly, when the x value decreases, then as you would imagine, the y value increases. That's why it's called the reciprocal, or it kind of flips it around there a little bit. So let's look at a basic example, probably the most basic one, y equals 1 over x. So here our constant k is the number 1, and the x is the variable, that's the piece that's in the denominator, that's going to be the part that keeps on changing. So let's look at a table and see what happens when we start plotting some of these values. Alright, so let's start with 1. So when x is 1, that means we've got 1 over 1, so the y value will also be 1. What happens if we have x as 2? Well, now we've got 1 over 2, so of course we're going to have 1/2. And we'll follow this same pattern, just grabbing some random values, 4 for x, and we get 1/4 for y, 10 for x, 1/10 for y, 100 for x, 1/100th for y. So if you notice here, exactly what we said up above is happening. As the x value is getting bigger, the y value is getting smaller. These are just getting smaller and smaller fractions. Remember, every time the denominator is a larger number, it's a smaller fraction. Okay? So what happens if we go the other way? What happens if we work from 1 towards 0? So let's say we have 1/2. Well, all right, let's plug this in. 1 over 1/2 equals, all right, so when we're dividing by a fraction, so 1 divided by 1/2, we multiply by the reciprocal, so we get a value of 2. So our y value is 2. What if we have 1/4? Well, we can follow this same idea that we've got 1 over 1/4. It's going to mean multiply by 1 times 4 over 1. We'll get 4. Right? So we're just kind of flipping it. We're just taking the denominator, popping it up there. So when we have 1/10, then that's going to be 10, and 1/100th, that's going to be 100. So keep in mind, as we graph this, we'll plot our 1/1. That's a nice easy one. All the rest of these are kind of fractional pieces. They're kind of hard to fit on here. But if you can kind of imagine what's happening is we're going to start getting a curve that looks kind of like this. And this is saying that we're getting really, as we get closer to 0, so we're moving left on the x-axis, the y value is getting really large. And as we move right on the x-axis, the y value is getting really small. And keep in mind that these are all just positive values for x, right? So we haven't even looked at the negative values. So this is just half of the graph of this function. So even though it looks like the full graph, it's only half of a graph. So this is a common thing that people get tripped up on, is they sometimes think that this function is there's two different graphs here. And we're going to see the second half here in a second, but the whole graph is one graph of this one function. Okay, so I'm getting ahead of myself though. So let's look at negative values. So what happens if we have -1 for x? Well, then we're going to have 1 over -1, which is going to simplify to -1. What if we have -2 for x? Well, now we're going to have -1/2. And keep in mind, as these negative numbers, as they look like they're getting bigger on the x, that actually means they're getting smaller, right, for our x values. So that's why I'm moving to the left, because x is getting smaller. So if we have x is -4, then of course we're going to have -1/4, and so on and so on. All right, so now let's get bigger in our negative x values. So now we've got to move closer to 0. So if we get x is equal to, let's say, -1/2. Now it's going to be like above, where we've got 1 over -1/2. We're going to have to multiply by the reciprocal, so we get a -2. So now our y value is negative 2. And what if we do the same thing for negative 1/4? Well, again, we're going to do 1 over negative 1/4, multiply by the reciprocal, and we'll get negative 4 for our answer. And finally, let's do 1 over negative 10. Again, flip it, multiply it, get negative 10. So again, if we can plot some of these values, again, it's going to be fractional, so they're kind of small, but we can at least get our negative 1 and 1, as we know these things move on, our negative 1 and 1 point here. And we graph this, and it's going to be kind of a graph that looks like this. So again, these are the negative values for x. So we get the two-part function, so to speak. So y equals k over x, or y equals 1 over x, you're going to have these two parts of the function. You're going to have 1 here in the positive x and positive y, which is a quadrant 1. You have 1 in quadrant 3. Okay? And keep in mind, though, that here that we never actually touch or cross the y-axis. And that's because, again, when we have y equals 1 over x, if x is 0, now we've got y equals 1 over 0, which means it's undefined, right? So we can't graph that. That's not possible to happen. So it never crosses the y-axis. And then similarly, we never cross the x-axis, or we never touch the x-axis, because if we look at our y values, they're either getting really big as we get closer to 0, or they're getting really, really small. They're getting infinitely small as x is getting larger or smaller, right? As it gets really large or really small. So, so that's the really big idea with this. So it's getting infinitely smaller there. So what we have is our x-axis and our y-axis are our asymptotes. And asymptotes, again, are those imaginary lines that our function approaches but never crosses. And we really talk about the end values with this. In this case, we're, what's happening at the ends of these functions. So as x gets really, really, really big, or x gets really, really, really small, it never touches or crosses these imaginary lines. Okay, so let's look at a couple examples and see how this shakes out if we're not looking at just the basic y equals 1 over x. So let's say we've got negative 5 over x. So here we've got two things that are going on, two things that are changing. Not only has our y, or our 1, changed to 5, so it's gotten bigger, but it's also a negative value as well. So it's bigger, the absolute value or the magnitude of it has gotten bigger, but it's a negative value. So let's see what happens when we combine those two pieces. So we'll make ourselves a nice table, plug in some values. So x is 1. Alright, so we're going to pick some easy ones and some maybe not so easy ones. So x is 1, y is going to be negative 5, right? Just plug it in and simplify. When x is 5, alright, so now negative 5 over positive 5, that gives us a negative 1. When x is 10, well, negative 5 over 10, that's going to be negative 1/2, right? Negative 5 over positive 10, simplify it out, negative 1/2. Now let's take something in the middle here too. So what if we got 3? Now this doesn't simplify as easily, so we're just going to leave it as negative 5 over 3, but we'll want to see where this comes into when it comes into our graph, so we don't have that big of a jump from 1 to 5, and we'll kind of see how the curve is changing. Alright, we already know it's not going to do x is 0 because that will give us an undefined function, so let's look to see what happens as this gets a little bit smaller though than 1. So if we go 1/2, right? So we're working our way towards 0, but not actually getting to 0. So when y is 1/2, we got negative 5 divided by 1/2, multiply by the reciprocal, and we get negative 10. So when x is 1/2, y is negative 10. What about 1/3? Same idea. Negative 5 divided by 1/3, multiply by the reciprocal, and we get negative 15. Alright, what if we take a negative 1/3? So we jump the 0, because again, the 0, we can't have x equals 0, so we jump it and see what happens. So negative 1/3 now. So negative 5 divided by negative 1/3, still multiplying by the reciprocal, and we get a positive 15. Negative 1/2 multiplied by the reciprocal, we get positive 10. Negative 1, we plug negative 1 in there, well, that's just going to give us a positive 5. So we can kind of see a pattern that's going on here as well. So let's get this thing graphed and plot some points. So if we look at our positive x-axis, or the positive x values, we can see that we're kind of getting these, the y values are all negative. And they're still approaching the x-axis, they're still approaching the y-axis, but they are still kind of making that curve. And that's why I did that 3 in negative 5/3 in there as well. So we kind of plot that point in there. And then we have this on the negative x value. It's up on the positive y side. So when we graph these, we get these two curves. So again, this is one graph. These two curves are one graph. And two things are happening here. So first, when we look at the original function, we can see that these things have flipped. So the y value has changed. So we're looking at the negative value, and they're actually flipping across the x-axis because all the y values are changing. So they're flipping across the x-axis. And the other thing to think about is what's happening here. So we still have our x and y equaling 0. As I mentioned, the y-axis and the x-axis are our asymptotes, right? We're still approaching those, but never reaching them. But the other thing to really think about is what's happening here. We're kind of pushing ourselves away from the origin, and that's the reason of that is that 5. So the 5 is kind of drawing it away from the origin, where the negative is getting it to flip across the x-axis. So those are the two things to really keep in mind as we look at this graph and this change. All right, so let's look at one other example. So now we're going to go back to our original 1/x, but now we're going to add 2 to it. And hopefully you're getting an idea of what's going to happen with these, because it's all the transformations for functions are very similar. When you study transformations, you're going to see that these things are all very similar. So hopefully you can kind of already get an idea of what's going to happen. We're going to make ourselves a table just like we've been doing. X is equal to 1. All right, so we plug 1/1 is 2, right? And so then we add our 2 in there, we get 3. So what happens if we plug 2 in for x? Now we've got 1/2 plus 4/2, right? That 4/2 is the positive 2 simplified to the same common denominator. So we get 5/2, and that's going to be what our y value is. What if x is 5? So now we've got 1/5, right? 1/5 plus 2, so we have to again change that 2 into 10/5, add our numerators together, we get 11/5, and so on. So now we've got 1/2 for our x, right? So we've got 1/1/2 equals, just like in all the other ones, we're going to multiply by the reciprocal, and we're going to get 2. And then we have to add that other 2 on there, so we're going to get a value of 4. So when x is 1/2, y is 4. What about when x is 1/5? Okay, multiply by the reciprocal, so we get 5 plus 2, and we get 7. All right, and these patterns are going to go on as we go up and x gets larger, and we can kind of see what's happening. Y is getting smaller. Okay, so we know that we're not going to approach, or we're not going to get to 0, because it's still, the x value can't be 0, because it gives us an undefined function. But we can look at the negative values as we get really small. So negative 1/5 multiplied by the reciprocal, so we get negative 5 plus 2, and so negative 1/5, so there's our negative 5, add our 2, and we get a result of negative 3. What about negative 1/2? So again, multiply by the reciprocal, so we get negative 2. Negative 2 plus 2 is 0. Now keep in mind, this isn't the x value that equals 0, this is the y value that equals 0, so that's okay. If we have negative 1, now we got negative 1 plus 2, so we get a positive 1. Negative 2, so negative 1/2 plus 2, we have to make the same common denominator. So we're going to have to increase that to 4 over 2, and that will give us a result of 3 over 2, so positive 3 over 2. And just one more example, negative 5, and so negative 1/5, and negative 1/5, change our 2 to 10 over 5, right? Negative 1/5 plus 10 over 5, add the numerators, so we get 9 over 5, and that keeps on going in that same kind of pattern as well. All right, so let's graph this thing. So let's start by looking at what's happening with these fractions for the y value. All right, so if we start with 5 over 2, that simplifies to 2/5, and 11 over 5 simplifies to 2.2. All right, and 3 over 2 simplifies to 1.5, and 9 over 5 simplifies to 1.8. So what happens here is if we kept on picking larger and larger values, we would see that this side and this side, the 2.2 would keep on getting closer to 2 from above, right? 2.2, 2.2, 2.1, 2.001, and so on. It would keep on getting closer to 2 from the top side. Whereas when we're going in the negative value for x, we're going to be getting closer to 2 from the bottom side, 1.9, 1.99, 1.999, and so on. So what happens is we've got this imaginary line at 2, and that is our asymptote. So that's the value that we're approaching but never reaching. And when we start plugging in some of our data points that we've taken from our table here, we can see that we're still getting this curve. And what happens is now we have a curve that comes up here and one that goes down here, and it just kind of keeps on going. So this is our our vertical shift. So when we add a value outside of our function with our transformations that you studied before, we get a horizontal shift up and down. If you're not familiar with those transformations, go back and check some of my older videos where we do talk about the transformations. But this shouldn't come as a surprise. The only difference is now that our asymptote is moving. So this positive 2 is now our asymptote, right? And that's the line y equals 2. So that's the big change for this. And that's the real thing to keep in mind. Now you can have other transformations which we'll look at in other videos, but I just wanted to look at what happens when k is negative, when k gets a little bit larger or smaller, like that 5 or negative 5, and what happens if we do a horizontal shift. Okay, so we can kind of pull away from the origins, or we can shift our whole graph up and down. So that's it for this video. Hopefully this helps with some of the ideas for the reciprocal function, and we will talk to you in the next video.